Welcome to Unit 7, Systems of Linear Equations. In sections 1 and 2 combined, we're going to be looking at what a system of equations is and also how we can solve systems of equations. So let's have a look. A system of linear equations will look something like this. 3x plus 4y equals 8, negative 2x plus 6y equals negative 2. Now the terms don't need to be necessarily arranged in this particular order. The idea is you have two linear equations with two variables. So you're used to dealing with one linear equation, graphing one line or solving one equation for x, but now we're going to be looking at two equations together. And throughout this unit we're going to be solving systems of linear equations. So when we solve, it means we're finding the x and y values that satisfy both of the equations. Sometimes you may find some x and y coordinates that satisfy the first equation but not the second equation. So that wouldn't be the solution. The x and y values need to work in both equations. So how are we going to be finding these x and y coordinates that satisfy both equations? Well, we're going to look at a variety of methods. Firstly, we're going to be graphing. So you can graph each line on the same grid. You can graph using tables of values, using a slope and a point, using your x and y intercepts, any of the methods that you previously learned. We'll also be looking at a couple of more algebraic ways to solving, one called substitution and another one called elimination. So you can choose any of these methods when you're solving systems. And besides solving, you're also going to have to create a system of equations from a word problem. So let's practice that now. It says a bakery sold 6 cupcakes and 2 donuts to a customer for $15, and they sold 5 cupcakes and 1 donut to another customer for $11.50. Write a system of equations that can be used to determine the cost of each cupcake and donut. So here we're just going to set up the system. We're not actually going to solve right yet. So whenever you set up a system, you should always choose some variables and then state what they represent. Now normally when you're dealing with linear equations, you use x and y, but when you're dealing with word problems, pick variables that are a bit more descriptive. So here we have cupcakes and donuts, so we can let C be the cost of a cupcake and D be the cost of a donut. So now to set up my system, I see that the bakery sold 6 cupcakes. So that would be 6 times C. And they also bought 2 donuts. So we can add on to that 2D. And that was a total of $15. So that could be the first equation in our system. Now another customer bought 5 cupcakes, so 5C, and 1 donut, so plus 1D, for a total of $11.50. So this is a system of equations that you can use to help you determine the cost of each cupcake and donut. Let's look at example 2. A movie theater charges different rates on weekdays than on weekends. In 1 week, when 123 people attended during the weekday and 253 people attended during the weekend, they made $4,143. Now the next week, when 92 people attended during the weekday and 302 people attended during the weekend, they made $4,452. We got to choose which system of equations represents the cost of each ticket, where D is the cost of a weekday ticket and E is the cost of a weekend ticket. So we have these 3 systems to choose from. So let's analyze each one. So to start, we have 123D in the first 2 equations and 123E in the last equation. But rereading the word problem, I see that 123 people attended during the weekday. So that means we can eliminate the bottom equation. Now looking at the 2 equations remaining, they both have 253E, but then they equal different amounts. Now I know in week 1 they made $4,143. It was week 2 where they made $4,452. So we can eliminate the first equation, leaving us with this one here. Now let's look at the second equation just to confirm. So in the second week, 92 people attended during the weekday, 302 people attended during the weekend, and they made $4,452. So that is correct. Now whenever you solve systems of equations, you should always verify your solution. And to do that, you're going to plug your values into both equations. So let's consider the previous example of purchasing cupcakes and donuts. Here's the system that we developed. So Irene solved the system and calculated the cost of the cupcake to be $2 and the donut to be $1.50. Are they correct? So let's go ahead and replace C, the cost of a cupcake, with 2, and D, the cost of a donut, with $1.50 in each equation. So for the first one, we would have 6 times 2 plus 2 times $1.50. Now when I work that out, I get 12 plus 3, which equals 15. And that's what we're looking for, so that is verified. Now for the second equation, 5 times 2 plus $1.50 equals 10 plus $1.50, which is $11.50. So again, that is correct. So these values were verified in both equations. So that means that Irene is correct. So that's your introduction to systems of equations. You can now move on to the next video where you'll look at solving by graphing.